ഹലോ അർജുൻ, റെഡിയല്ലേ? ഉണ്ടല്ലോ. ഹലോ അർജുൻ, കേൾക്കുന്നുണ്ട്? ആയിക്കോട്ടെ ആയിക്കോട്ടെ ആയിക്കോട്ടെ. അത് കഴിഞ്ഞ റെഡി ആകുമ്പോൾ നമ്മുടെ സാറിൻ്റെ അടുത്ത് പറയാം ഡയറക്റ്റ്. വന്നില്ലേ? സാറിന്റെ കോട്ടി എല്ലാ തരത്തിലും സംസാരിച്ചു.
MS ഡിസ്കണക്ട് ചെയ്യാമോ സാർ?
പാട്ടൊരു സുഖമല്ലേ? ഇറങ്ങോ?
MS ഡിസ്കണക്ട് ചെയ്താ?
മാറും. എല്ലാവരും അവിടെ നോക്കിക്കൊണ്ടിരിക്കണം. ഹലോ ഹലോ, നമസ്കാരം.
Good afternoon to all respected dignitaries, invited guests, faculty members, students, and participants. A warm welcome to each one of you to the PR Pisharoty Memorial Lecture, organized as a prelude to the 38th Kerala Science Congress. The Kerala Science Congress, organized annually by the Kerala State Council for Science, Technology and Environment, continues to be a premier platform for scientific exchanges and interdisciplinary dialogue. This year, the 38th Kerala Science Congress will be held from 30th January to 2nd February 2026 at St. Albert's College, Ernakulam. As a part of this year's academic programs, 9 memorial lectures have been instituted to honor eminent luminaries in science, 7 of which are being conducted as preludes to the main event at the premier institutions in the state. Today, we gather here for the PR Pisharoty Memorial Lecture, paying tribute to Dr. PR Pisharoty, who is widely recognized as the father of remote sensing in India and whose research has laid the foundation for studies in meteorology. Before we move on to the formal ceremony, we will now watch a short video showcasing the initiatives of KCST.
Kerala State Council for Science, Technology and Environment, popularly known as KSCSTE, was constituted in November 2002 to encourage and promote science technology related activities in Kerala State. It was done by reconstructing the erstwhile State Committee on Science, Technology and Environment, which was established in 1972 in concurrence with the science policy of the Government of India. Over the past 2 decades, KSCSTE spearhead the science and technology activities of the state in general and its own R&D centers in particular. With its headquarters in Thiruvananthapuram, 7 R&D centers, 3 grant-in-aid institutions, 2 centers of excellence and 3 science parks are functional under the council. Our R&D centers are Center for Water Resource Development and Management, Kundamangalam, Kozhikode, Malabar Botanical Garden and Institute of Plant Sciences, Pokkunnu, Kozhikode, Kerala Forest Research Institute, Pichi, Thrissur, Institute of Climate Change Studies, Kanjikuri, Kottayam, Srinivasa Ramanujan Institute of Basic Sciences, Vellur, Kottayam, Jawaharlal Nehru Tropical Botanic Garden and Research Institute, Palod, Thiruvananthapuram, National Transportation Planning and Research Center, Ernakulam, Thiruvananthapuram, Sophisticated Test and Instrumentation Center at CUSAT, Kochi, Community Agro-Biodiversity Center at MS Swaminathan Research Foundation, Wayanad, Integrated Rural Technology Center at Palakkad are the grant-in-aid institutions of KSCSTE. KSCSTE has also facilitated the establishment of Sri Chitra Tirunal Institute of Medical Science and Technology, Rajiv Gandhi Center for Biotechnology, National Center for Earth Science Studies, and Institute of Advanced Virology. At the headquarters, we initiate several programs to advance the science and technology objectives of the state. Programs for students include Scheme for Promoting Young Talents in Science, Student Project Scheme, and the Pratibha Scholarship for UG and integrated PG students. For researchers, we have KSCST Research Fellowship for PhD scholars, Postdoctoral Fellowship for post-PhD research, Partnering Academic and Industrial Research Scheme to promote translational research through academic-industry linkage. Our programs for mid-career researchers include Ecology and Environment Program, Science Research Scheme, and Engineering and Technology Program. Programs for women in science include Back to Lab Research and Postdoctoral Fellowship. These programs support women researchers with a break in career. KSCSTE also operates an entrepreneurship development program for SC/ST women in STEM. To support R&D initiatives from superannuated scientists, we operate the Emeritus Scientist Scheme. Selective augmentation of research and development and Shastra Bhoshani science labs for government high schools in Kerala are 2 of our science infrastructure development programs. Under Shrestha program, KSCSTE nurtures Center of Excellence for world-class research in various domains. Our programs for technology development include APJ Abdul Kalam Youth Challenge Program, Rural Technology Program, Technology Development and Adaptation Program, and Engineering Support and Coordinated Research for Specially Talented Children. We initiate environmental conservation in the state by Environmental Information Awareness Capacity Building and Livelihood Program, National Green Corps, and Wetland Technical Unit. The Kerala Biotechnology Commission supports biotechnology development programs, which include biotechnology research support, schemes for industrial collaboration, and entrepreneurship development in biotechnology, Young Investigators Program in Biotechnology, Kerala Biotechnology Re-Entry Fellowship, Biotechnology Innovations for Rural Development, and our capacity building initiatives, notably the DBT Skill Vigyan Program and Human Resource Development in Biotechnology. Activities of the Patent Information Cell and the Intellectual Property Rights Information Centre Kerala facilitate IP awareness and patent-related activities. KSC-STE Scheduled Caste and Scheduled Tribe Cell is a DST-supported project that provides S&T solutions for the development of SC-ST communities. KSC-STE Shastra Puraskaram, Kerala State Young Scientist Award and Science Literature Awards are notable science and technology awards instituted by the Council. KSC-STE is honored to recognize legendary scientists and science advocates through the Kerala Shastra Puraskaram. The National Children's Science Congress, Technology Festival, and Rural Innovators Meet are other important science popularization programs. KSC-STE also supports the observation of National Mathematics Day and National Science Day programs in the state. Kerala Science Park is a new initiative facilitated by KSC-STE for R&D development in the state. Centers of Excellence in Microbiome and Nutraceuticals are the two new initiatives facilitated by KSC-STE. Kerala Science Congress is an annual event of KSC-STE. The event includes 9 memorial lectures to honor the S&T visionaries and to cherish their contributions. Focal theme sessions, technical sessions bring together researchers in various domains. National Science Exhibition is another highlight of the Kerala Science Congress. Sessions like Walk with Scientists, SciSoul, PG Interaction Session are also organized as part of the event. The 36th edition of Kerala Science Congress evinces the presence of 2022 Nobel laureate in chemistry, Professor Morton P. Meldal, addressing the gathering. A celebration of science, innovation, and collaboration, the Kerala Science Congress has, through its many editions, united Nobel laureates, eminent scientists, and emerging researchers. It stands as a testament to Kerala's commitment to advancing knowledge, inspiring generations, and driving discovery for a better future. The 38th edition of Kerala Science Congress is scheduled from January 30 to February 2, 2026 at St. Albert's College, Ernakulam, with the focal theme, Ocean Science for Blue Economy and Ecosystem Restoration. Kerala State Council for Science, Technology and Environment, advocating science and technology innovation in service of the state of Kerala.
It's a privilege to invite our distinguished dignitaries to the dais. Professor M. Junaid Bushri, Honorable Vice Chancellor of Cochin University of Science and Technology, Dr. Sajish T.H., Vice Principal of St. Albert's College, Kochi, Dr. Aldrin Anthony, Head of the Department of Physics, Cochin University of Science and Technology, Shri Arjun Prasad, Scientist, KSCST, and Dr. Deepthi B., Junior Scientist, KSCST. May I request the dignitaries to kindly occupy their seats on the dais. Due to some unforeseen circumstances, our distinguished Shri A. Rajarajan, Director of Vikram Sarabhai Space Center, Thiruvananthapuram, will not be physically present today. He has joined us online. To commence the formal proceedings, I invite Dr. Aldrin Anthony, Head of the Department of Physics, CUSAT, to deliver the welcome address.
Good afternoon, all. Respected Honorable Vice Chancellor, Professor Junaid Bushri, and our distinguished guest and the speaker, Sri A. Rajarajan, and our representative from KSST, Dr. Arjun, Sri Arjun, and also Deepthi, and respected teachers, students, other faculties, and non-teaching. So it's actually, so we are conducting as a part of this Kerala Science Congress. It's the second time that KUSAT is organizing this memorial lecture. Last year, we hosted the Thanu Padmanabhan Memorial Lecture. And this year, it's a PR Pisharoty Memorial Lecture that we are hosting here in KUSAT. So since being a head of the Department of Physics, and since the university has entrusted me to coordinate this program, Department of Physics feels this is a very proud moment for our physics department to host this particular program, because PR Pisharoty was a graduate and PG in physics stream. Later moved on to the area of atmospheric science. So I think I remember when I was doing my master's here in KUSAT, that is in 90s, 93, after 93, 96. I think one of the year, I don't remember exactly, Pisharoty has visited Cochin University during that period. So I don't have any much memory, but I remember that that time that he has visited KUSAT that period. And so I don't want to prolong much. And so first of all, I would like to especially congratulate KSST for organizing such memorial lectures every year. And so there are 9 memorial lectures, and this is one among them. And I think this is going to be the 6th one. Another 3 will be done along with the Kerala Science Congress, which is going to happen in Ernakulam at St. Albert's College during the end of this month. And first of all, I would like to welcome our Honorable Vice Chancellor, Professor Junaid Bushri, who is always ready to support for every event, and in his busy schedule, he is also here. So I welcome you, sir, for this gathering. I would like to, next is our distinguished speaker, our distinguished guest, Sri Arjun Prasad. So you may know he's having a very busy schedule, and we were expecting him here in KUSAT because last few times to host our VSSC or ISRO directors here in KUSAT didn't happen. And I think it's the 3rd time in a row that I think this time also we are not able to host the ISRO or VSSC directors due to some unforeseen reasons. So he's totally busy at this time, and we understand his busy schedule. And we are grateful, sir, for finding time to be here for this particular program, and welcome you, sir, for this program. So next, I would like to invite Dr. Sri Arjun Prasad, who is a scientist at KCST, who is the main person who is entrusted by KCST to organize this program. Welcome, Dr. Sri Arjun. Next is we have also a guest from our Dr. Sajish TH. Sajish is also an alumni of a Department of Physics, and now he is the Vice Principal of St. Albert's College and also as a faculty in space of the Department of Physics at St. Albert's College. So Sajish is here to introduce the Dr. PR Pisharoty, and I welcome Dr. Sajish to this program. Next is our Dr. Deepthi B, who is a junior scientist at KSSTE, and I welcome Deepthi to this program. So I would like to welcome all other faculty members and students, and I hope you will have a good very interesting talk from our director. And at the same time, I would just like to point out, our students have been very active with the different activities with space things. For example, I think we had even our School of Engineering students have even done a rocket launching, like with balloons with the help of Atmosphere Science Department. a couple of years back. And also they have some programs like IRIS, innovation and research activities with regard to the space. It's a student group which they are doing every year. There's a program also like a space program. They are organizing every year in Cochin University. And so there are also representatives of these student organizations, with student clubs who are working in this space-related activities. And I wish you all a good deliberations here and enjoy the scientific deliberation. And welcome you all once again. Thank you.
Thank you, sir. May I now invite Professor M. Junaid Bushri, Honorable Vice Chancellor of Cochin University of Science and Technology, to deliver the presidential address.
A very warm good afternoon to one and all. Respectful Chief Guest of the Day, Dr. Rajarajan, Director, Vikram Sarabhai Space Center. Respectful Head of the Department, Dr. Aldrin Anthony. Respectful Dr. Sajesh, Vice Principal, St. Albert's College. Respectful Arjun Prasad from Scientist KSST. Respectful Dr. Deepthi, Scientist KSST, dear faculties, students. So all of us know it is a very happy moment as far as our university is concerned. And Kerala State Council for Science, Technology, and Environment is continuously organizing Science Congress for the last 37 years. It is a proud moment as far as Kerala State is concerned. This is the only one state council which is used to organize Science Congress every year without any break. I think there won't be any break. So this is the 30th edition of Kerala Science Congress, which is going to be held in Ernakulam. It is by the end of this month. In connection with this 30th Science Congress, KSST is organizing different lecture series, and last year also organized a similar lecture series. And this year, they are particularly, their focus theme is related to the blue economy and ocean economy of this year. And this particular lecture is focused with respect to, in memory, it is a memorial lecture of the P.R. Pisharoty. I think Dr. Saresh will introduce more about P.R. Pisharoty. He is actually the father of the Indian remote sensing. And he is the recipient of the Padma Award, Padma Shri of the 1970. And he is also the recipient of the prestigious Raman Centenary Award in the year of the 1988. Actually, he is one of the proud son of the soil of Kerala, field of science. Anyway, KSST selected him. He is also, KSST is organizing this particular event in his memorial lecture. Is a happy news for it. Is an inspiration for the youngsters to come, inspiration for the youngsters in the field of science. And Dr. P.R. Pisharoty is also fellow of the prestigious Indian academies like the Indian National Science Academy, Indian Science Academy, etc. And he is instrumental in developing remote sensing techniques for the wilt disease of coconut. So he has made a lot of contributions in the field of remote sensing and climate modeling and climate studies, etc. Unfortunately, today we have a speaker from the same field, Dr. Rajarajan, Director of the Vikram Sarabhai Space Center, India's prestigious Indian Science, one of the wing of the India's prestigious Indian Science in ISRO. And I take this opportunity to welcome once again to welcome Dr. Rajarajan for delivering this prestigious lecture, Dr. P.R. Pisharoty Memorial Lecturer on behalf of the KSST and the Cochin University of Science and Technology. Welcome, sir.
Thank you. Thank you.
And I feel I request all of you to interact with Dr. Rajarajan, even though he is the director of one of the biggest scientific organizations in Kerala, and he is having a very busy schedule, but he find time to spend time with us. So please interact with him, and of course that will be a very definitely it will be useful for the people, those who are interested in areas related to the Indian Space Research Organization. I take this opportunity to, I'm not taking much more time because our speaker is waiting for all of us, and I take this opportunity to congratulate Kerala State Council for Science, Technology and Environment for selecting Cochin University for organizing this prestigious event at Cochin University of Science and Technology. I wish all the best for the 30th edition of the Kerala Science Congress, and I request all of you as active participation in the 30th edition of the Kerala Science Congress, and I wish all the best for the P.R. Pisharoty Memorial Lecture at Cochin University of Science and Technology. Thank you all.
Thank you, sir. It's a privilege to hear from Dr. Sajeesh T.H., Vice Principal of St. Albert's College, Kochi. Sir, requesting you to present a brief introduction to the life and contributions of Dr. P.R. Pisharoty.
Respected President of the function, Professor Dr. M. Junaid Bushri, Honorable Vice Chancellor, Cochin University of Science and Technology, our distinguished Chief Guest and Speaker of the Day, Shri A. Rajarajan, Director, Vikram Sarabhai Space Center, sir is joining us virtually for this event. Dr. Aldrin Anthony, Associate Professor and Head of the Department of Physics, Cochin University of Science and Technology, Shri Arjun Prasad, Scientist, Kerala State Council for Science, Technology and Environment, and the convener of the focal theme and memorial lecture series for the 38th Kerala Science Congress 2026, Dr. Deepthi B., Junior Scientist, Kerala State Council for Science, Technology and Environment, distinguished scientists, respected faculty members, research scholars, students, and the audience joining us through the YouTube live streaming. Good afternoon to one and all. It is indeed a privilege and honor to introduce one of the eminent scientists in whose memory we are gathered here today, Professor Pisharoty Rama Pisharoty, a visionary whose pioneering work laid the foundation of atmospheric science and remote sensing in India. Professor Pisharoty is widely revered as the father of remote sensing in India. A distinguished physicist and a meteorologist, he played a seminal role in shaping India's capabilities in meteorology, satellite applications, and atmospheric research, areas that remain central to both scientific progress and national development. Born on 10 February 1909 at Kollangod in Palakkad district to Srimati Lakshmi Pisharasya and Sri Gopala Vadyar, Professor Pisharoty had his early education in Kerala. He went on to earn his BA honors in physics from St. Joseph College, Trichy, and completed his postgraduate studies in physics from Madras University. He began his academic career as a lecturer in physics at Loyola College, Chennai, serving from 1932 to 1941. During this period, he spent his summer vacations at the Indian Institute of Science, Bangalore, pursuing research under the mentorship of the legendary Nobel laureate, Sir C.V. Raman, an association that deeply influenced his scientific approach and rigor. On the recommendation of Sir C.V. Raman, Professor Pisharoty joined the India Meteorological Department IMD in 1942. At IMD, he made significant contributions to the study of thunderstorms, western disturbances, and monsoon depressions, work that substantially advanced weather analysis and forecasting in India. In early 1950s, he proceeded to the University of California for advanced studies, where he worked under the internationally renowned meteorologist Jacob Behrens. He obtained his MS and PhD by 1954. His doctoral research made important contributions to the understanding of atmospheric energetics, particularly the role of tropical heat in driving large-scale atmospheric motion. Professor Pisharoty was also a visionary institution builder. From 1962 to 1967, he served as the founder director of the Indian Institute of Tropical Meteorology, Pune, laying strong scientific foundation for atmospheric research in India. After his retirement, he joined the Physical Research Laboratory, PRL Ahmedabad, at the invitation of Dr. Vikram Sarabhai. Subsequently, he served as the director of Remote Sensing and Satellite Meteorology at the ISRO Space Application Center. Among his many pioneering achievements, Professor Pisharoty led India's first successful remote sensing experiment. In a pioneering and now well-known experiment, he used an aircraft-based sensor to detect coconut wiltroot disease in Kerala. This experiment remains a landmark demonstration of the practical application of remote sensing in agriculture. A prolific scholar, he authored seminal research on X-ray diffraction and influential books such as Monsoon and the biography of Sir C.V. Raman. Professor Pisharoty also held several prestigious international positions. He served as the chairman of the Scientific Advisory Board of the World Meteorological Organization, WMO, and was a member of the Joint Organizing Committee of the Global Atmospheric Research Program. In recognition of his outstanding service to science, he was awarded Padma Shri by the Government of India in 1970. He received IMO Gold Medal of the World Meteorological Organization in 1989, and he was the first recipient of Raman Centenary Medal. In his honor, Indian Society of Remote Sensing has renamed its National Remote Sensing Award as the P.R. Pisharoty Memorial Award. Although Professor Pisharoty passed away in 24th September 2002, his legacy continues to inspire. Significantly, the GPS radio sonde developed by Vikram Sarabhai Space Center is officially named as Pisharoty Sonde, a lasting tribute to his contributions. It is therefore historically fitting that Sri A. Rajarajan, the director of Vikram Sarabhai Space Center, the very institution that keeps his name alive, is joining with us virtually to deliver this memorial lecture. I respectfully invite everyone present here and online to listen and inspired by the life of a man who looked at the sky to better understand the earth. Thank you.
Thank you, sir. May I request Shri Arjun Prasad, Scientist KSCST, to introduce our speaker for the day.
Good afternoon, ladies and gentlemen. It's my privilege to introduce the speaker of today's memorial lecture, Sri A. Rajarajan, distinguished scientist at ISRO, who assumed charge as director VSSC in August 2025. He's a member of the INSPEC board and Space Council. Formerly, he was director, Satish Dhawan Space Center, Sriharikota, which is known as the Spaceport of India. His sustained contributions and technology leadership at ISRO has been transformative for making our nation self-reliant in the field of space technology. He was instrumental in several prestigious missions of ISRO like Human Space Program, Gaganyaan, and Small Satellite Launch Vehicle. He has equipped the center to concurrently meet the launch-based infrastructure of ISRO and commercial space industry in line with new space policy. He's in the forefront in enabling strategic technology development of solid propellant motors through a group of industries. He also scripted history by launching the first ever private rocket of the country, Vikram S, which has opened a new arena for the space programs. He used COVID-19 induced disruption as an opportunity to optimize resources and introduced several innovative technologies. During his career spanning nearly 4 decades, he has held several positions of leadership at VSSC, where he held senior positions as deputy director of 3 major entities. During this period, he specialized in design and development of launch vehicles and spacecraft composite systems, including carbon-carbon composites, and paved way for building a technology center of excellence in the composite area. He was instrumental in outsourcing of solid rocket motor production, utilizing available propellant manufacturing facilities available with industry. He's also presently the vice president of several societies, and he has several international journal and conference papers. He has been awarded the honorary doctorate by Satyabama University, Chennai, for his excellent contributions for space applications. In recognition of his meritorious contribution for space research, he has been felicitated with several awards and honors, including ISRO Merit Award and Team Excellence Awards. With these brief remarks, I have great pleasure in inviting Sri A. Rajarajan, distinguished scientist and director, VSSC, to deliver the PR Pisharoty Memorial Lecture. Thank you.
Thank you, sir. We now come to the highlight of today's program, the PR Pisharoty Memorial Lecture. It's our honor to invite Sri A. Rajarajan, Director of Vikram Sarabhai Space Center, Thiruvananthapuram, to deliver the memorial lecture. As we proceed, the dignitaries on the dais may kindly occupy their seats off the dais. May I request everyone to kindly keep your mobile phones in silent mode to ensure the smooth conduct of the memorial lecture.
Thank you. So can I proceed? Am I audible?
Yes, sir.
Thank you. So, thank you, Honorable respected Vice Chancellor, Dr. Junaid, the Vice Chancellor of Cochin University, Dr. Sajeesh, Head of the Department, Physics Department, Dr. Arjun Prasad, Dr. Deepthi, and all the dignitaries on the dais and off the dais, and all those assembled today for the 38th Kerala Science Congress as part of this lecture. First of all, I am honored and humbled to be invited for this lecture. I was really looking forward to travel to Kochi for this lecture. As obvious reasons, I was not in a position to travel. There are pressing work here. But however, as a part of my responsibility from a prestigious institution like VSSC to present before the student community or the academia, I don't want to miss this opportunity. So I want to be at least virtually present and present some of my thought process in the Indian space program. And also Dr. PR Pisharoty is a well-known figure, a renowned figure, always in our hearts, one of the pioneers along with the people who made this remote sensing a grand success in Indian space adventure. So Dr. PR Pisharoty is an institution by himself, and I take this pleasure to be part of this lecture series and be one of the person to present the Pisharoty Memorial Lecture. I once again thank CUSAT for giving me this opportunity. So, having said that, I just want to put a perspective on the past, present, and future of our space exploration, how it's going to go, along with application. We are one country unique where we started using space technology for the application purpose. I will just venture into some of these things. So, having done that, as you all know, Dr. Pisharoty has one of the mainstay in orienting our application-oriented space technology that's been put in use from the very early things from the late 60s. We started, and we had some of the leads in some of the areas, and we pay tribute to him, and that's what oriented along with our great visionaries. As you all will be knowing, hope my slides is visible.
Yes,
Hands up is okay for me. Okay, fine, thank you. So my presentation will be covering the space journey, the motivation and context, some of the ISRO's evolution and the milestones, some achievements, the challenges, then application, then what we are planning towards the future of mankind, what we have to do as part of a responsible nation, and some economic benefits and spin-offs. As you all know, the Indian space journey is being done by two pioneers. Definitely Dr. Vikram Sarabhai, the father of the Indian space program, the founder. As you all know, is very famous quote that we will not be second to none. We should be the second to none in the application of advanced technologies in the Committee of Nations to address the real problems of man and society. And it is Dr. Professor Satish Dhawan who took over and productized many of the application programs and made this emphasis that we have to utilize the national expertise and capabilities in all our programs, that we are looking inwards and make sure that we maximize our potential in all the areas, in our all programs. And that is the one which these two people put the trendsetters. You all know by this time, it's a very well-known documented story that we had a very modest beginning at the equatorial, the magnetic equator near Tumba, started in a church today, which is the Space Museum. So where we started in 1962 with all those Earth's magnetic field and taking care. It is a very humble beginning. The real pursuit of science started here in space area. As you know, some of the early days is handled by a dedicated set of youngsters, handpicked and selected by Dr. Vikram Sarabhai. Some of them are pioneers today, well-known names in this place, including Dr. P.R. Pisharoty, who joined in meteorology, Dr. Abdul Kalam, so many pioneers, Dr. Yorao, Kasturirangan, so many on. It is the very purpose is to develop our own missionaries. You imagine in the 60s venturing into making sure to develop our own missionaries for space technology. That is because nobody is going to give these missionaries. So we do it, and whatever way of means we found, we never got worried by what others will think of us. We started our own, treaded our own path. Always the nature bestows on those who venture and take the innovative ways and fields. Those who go the first transcend mover gets the benefit. That's what we happened here. So we are able to harness the space technology, and while pursuing this technology, some of this we are showed. We are many people may not know, even in the late 60s, it is Vikram Sarabhai thought of the DTH program, which you are all seeing now, that is satellite, to see how a direct-to-home telecast can be made use to make the farmers aware of the weather and other situations without going and trying to incur. This is one of the very advanced, ahead of his age thought process, which was made fruitful in 1974 with the ICE program. So the beginning of the space program era is like this. In 21st November 1963, we launched the first sounding rocket, the Niki Apache. and the indigenous sounding rocket in 20th November 1967, and the Tumba Yucatel rocket launch station was dedicated to UN on 2nd February 1968. And these are some of the humble beginning, thinking that what kind of program you can set in. As you know, all know, the journey from sounding rocket that we got in 62s and 67s to today's venturing to put a person in space and bringing back, and by 2040 to go to moon and come back, is started with Dr. Abdul Kalam Saab, the project director of SLV-3, very humble beginning, started with SL-3 in 18th July 1980. Ever remembered for that pioneer activity. Some of the technologies used in this program is much ahead of its time, like composite technologies were more used in 70s and 80s itself. Over the years, after establishment of ISRO in 1969, by institutionalizing and programming and projectizing the many programs, we had many milestones. That's what I have put it here, with culminating today with the NASA, ISRO satellite operator, one of the costliest satellite ever built and flown space, giving valuable data for the resources and other aspects, climatic changes. So some of these, always I have put only some of the milestones, which is very, very important, which decided how do we go about, both in technology, achievement, applications, and the purpose for which the humankind is there today here. As you all know, we have more than spread across all over India. These are all available in any of the applications here. So just I put here various features here. Various domains of space technology have been put in places, mainly concentrated on launch vehicle technology in Trivandrum and Mahendragiri, and the Bangalore, Ahmedabad on spacecraft technology, Hyderabad and other pieces and applications, and there are many application centers which use of this. As on today, we had 239 missions with PSLV, GSLV, LUM-3 and SSLV. We are one of the few spacefaring nation or the institution which is having a variety of vehicles which we are trying to do with. We have handled 434 satellites of 34 countries, and also some of the technology demonstrations like the pad abort test when we want to take a human, the crew module for atmospheric re-entry, and some of the space journey for inflatable to bring back the vehicle, some of the partially used vehicles to back, and some of the actions that we have taken. So far we had one Gaganyaan mission to showcase that we can, any mishap happens, we can bring the human safely back to the Earth. So some of the launch vehicles that we can see is, I just listed it down, starting with the 35 kg payload capability of SLV-3 to 6-ton capability of LUM-3, and a very cost-effective launch vehicles of small launch vehicle, costing less than 50 crores for a 500 kg payload. Now, even today, the PSL is facing some of the issues to some inadvertent areas. The versatility cannot be missed. This is one launch vehicle which can go to the LEO mission, the GTO mission, and the SSO mission in any angle of the Earth. The capability to versatility to maneuver and finding the azimuth and all the aspects and the trajectory. Some of the important satellites like orbital mission, the Chandrayaan-1 and Astrosat, Aditya, and the meteorological satellite and the SRE for the recovery, space recovery capsule, all has been launched using this vehicle. Just, it's only a, for want of time, I will stop this video presentation. I'll just look up only the LUM-3. Or shall I play? Time is there. Yeah. The first, the control systems ignites, and then only the launch vehicle will ignite and go ahead. Just I want to show that the control systems all made sure that it's ready, then only it starts firing. The main part of this item is around 290 ton is being lifted with an acceleration to reach up to 8 kilometers per second speed to be important on the vehicle. And that's what I am trying to develop on the launch vehicle technology, the power that it here to generate. The second is the launch vehicle is a geosynchronous satellite launch vehicle capable of the lift-off mass is 416 ton with a capability of 2.1. We are improved to 2.4 ton, and NISAR was lifted using this launch vehicle. I'll just give you this. Here is the point is we are launching with the 4 solid and 4 liquid engines. One of the biggest advantage of this vehicle is we can lift this vehicle even after the L40 4 engines are fired. We can stop the vehicle if the initial ignition is not as we expected. And that is one of the greatest advantage of this one of the vehicle. It is one of the most safest vehicle to take humans. But however, to take it into the real purpose, we require a huge vehicle which is under development. Now coming to the new workhorse for ISRO, the LVM3, the capability is 4.3. We are now improving to 5 ton and 5.5 ton. It has an improved reliability because it has only 3 stages, 2 strap-ons, the core 110 ton liquid engine and a 32 ton cryo engine. And it is rated for the human rating, and that is where it comes with a semi-cryo. We will be having a 6 ton, and for a human mission, we can go up to 9.5 to 9.8 ton capability. And the prestigious the first operational flight itself had a Chandrayaan 2. That is a case of reliability of this vehicle. And Chandrayaan 3 also was went in, and many customers are asking for this one vehicle. The entire world looks for this vehicle because it has a very lot of flexibility for both SSPO as well as synchronous capability. The total capability is a 691 ton is the lift-off mass, out of which the 400 tons is being fired by the both strap-ons. That's what you see, the tremendous force. But still the force which it happens is very, very in line with the contemporary vehicles. And within 120 seconds, the entire 400 tons is fired to lift off against the gravity of the earth. That's what we look, because India is kept in a unique place where we have surrounded by a lot of countries. So we have to be very careful where we jettison our segments and motors and putting it in real things. This is one of the great example of launching 36 satellites in different orbits, in different angles. And that's what we are trying to show in the real time. Okay. To take care of the cost effectiveness, when we are talking about 6 ton, we also have to look at when the electronics and other aspects get miniaturized for the same purpose. The satellites, we want to load many mini satellites, and within a 500 kg payload, we require a cost-effective vehicle, and that's what the small satellite launch vehicle that we have named it, which can lift off a 500 kg with a 120 ton lift-off mass and carefully put many satellites in the 500 kilometer orbit, which is very useful for remote sensing and new communication. And as you know, for atmospheric studies, we are so far 2,297 launches so far from Tumba, Sriharikota, and Kulasekharapattnam, Balasur. We did a lot of launches, and this is what the breakup we are given in Ters, Shah, and Balasur and Kulasekharapattnam. And we have many types of launches for different experiments. It is a very low-cost platform for doing some of the experiments for a minute or two, which can help us. And using this, we are also doing a air breathing technology that's called scramjet demonstrations. And RH-200 is the most launched rocket here on the right side. I'll just develop on to the students some of the engineering challenges in the launch vehicle design. It is a multidisciplinary. There is not one course which you can look at it. As you delve from electronics, mechanical, chemical, the interdisciplinary, the aerodynamics, the aero, the mission design, the control electronics, control design, the structural engineering, everything plays a part and each one has an effect on the others. And this is where the system engineering plays a big part and many parts expertise. No one person can become expert in all the areas. So considering this, I just put down some of the way, how do you manufacture, design should be, ease of manufacturing should be brought in. The system reliability people should be able to make out by the way in which you manufacture, how reliable that system is going to be. Some of the things is called planning, where you do a lot of things. And I'm proud to say in Indian industry, we have a lot of chemical experts, pioneers, and in Indian industries, who developed many of the propellants with which we are self-sufficient in such kinds. And we are able to go ahead and pour in many propulsion systems. Almost 93% of 94% of the vehicle is indigenous. So that's what some of the glimpses that has been made in Indian industry is being shown in the right side. One of the steps in what I just put it, once you decide on the choice of propulsion system and the power that is going to depart, the aerodynamic characterization, that's what I illustrated here. Then we have to look with this kind of aerodynamic load that is coming on the vehicle, with the energy that a vehicle can impart, we have to design a trajectory design, then the control and guidance, then we do thousands of simulations, and the constraints offered by the launch stations also taken into this one. Once this is done, we compartmentalize the stages, then the propulsion system design takes over, then the detailed designing like avionics, structures, control that we talk about. Then we look at this, what are the possible industries that can do this work and how do we test it. Then we do a trial, that's what I'll hold all the parts on the right side. The launch complex interfaces, that is, it is like an aircraft. You can't make an aircraft which cannot be handled by any of the airports, right? Same way, when you make a launch vehicle, the launch pad should be capable of interfacing with the launch vehicle, communicate with the launch vehicle, fuel the station. So whenever an aircraft is made, the entire airports will be alerted in what kind of system is being developed, how they will manage. This is a long system. Like that, here also we do, and a lot of test stations should be put in place to get the telemetry from the launch vehicle and get the data. So this is how the whole process, planning process starts and launch vehicle. I just put in a nutshell for a glimpse. This book itself is written by some very good people like Dr. Shivan and this one, who can give you various features of the launch vehicle designs. The integration design and launch process is further put. Now I'll get into the major science missions of ISRO, which is what is my interest is always. The first one, undoubtedly, Chandrayaan-1. It is Dr. Abdul Kalam's legacy that we have to have a probe to land on moon, even if it's hard hit. So we had a probe, and this satellite discovered that presence of water molecules. The mini magnetoscope and the chemical geological mapping, many of the aspects has been done by this spacecraft, which is launched through launch vehicle. I'll dwell upon this. It is on October 22, 2008, it was launched, and the mission ended in August 29, 2009. And we had many innovations, like some of the classified results. Some results are new for this kind of launch vehicle, satellites, which really helped us in understanding the moon the first time. As you know, the Chandrayaan legacy is the water in the atmosphere, which I told. The chase instrument really gave the technology. And then the water ice was discovered by NASA's M3 instrument on board Chandrayaan-1 orbiter. Both instruments corroborated the results one after other, and we were able to map the entire Earth and looking at some of the ices. It gives hope that one day, not in the near future, our humans is going to live in space, on moon. That possibility exists. Now, coming to Chandrayaan-3, we all know the famous quote that India is on the moon. The objective is to demonstrate that we can soft land on another celestial body, indicating that the time to reach there is also coming closer. We know how to go there, how to reach a location, and how to land, and that's the most important. It is actually, people used to ask, why this kind of mission? If human has to endeavor the fragilities of the moon and atmosphere, you are in a cocoon where we are protected by an Earth's atmosphere and living safely. Many planets doesn't have such kind of protective cover by which you are able to live. But as we start exploiting, human race is a very greedy species. We want our dil mange more and always look for more and more minerals and resources. We may be forced to, if we want to exist in this millennium of universe where we are, our part is tiny, and survive for another 1 lakh of years, it is no doubt we have to go in search of other celestial bodies and start living and possibility in space and other places. That possibility definitely exists. That's what is going to be there. Because there are many advantages, and we as a technology-driven people, we should be able to look at how to habitate this place. That is one of the reasons for this. So Chandrayaan 3 definitely demonstrated our capability, and that's why we have series of Chandrayaan program. It is not one-off program. It started way from in 2002. Today we have a lot of programs to go to Chandrayaan, the Chandrayaan 4, Chandrayaan 5, culminating with the moon mineral missions, landing mission, exploratory on moon, and then putting our Indian on the moon by 2040. That is the program that we have. Now, undoubted success is the Mars orbiter mission, where we are on the country which went to first country to have success in the first mission itself, first attempt, and we had lot of information on the Mars. And what is beautiful is we had a 2 years of life planned for 6 months minimum, but we have more than 8 years of observations of the by the Mars orbiter mission, and we had so much information on now on the Mars mission. We can try to now look confident to venture for a mission to drop there, go and put a satellite in Mars or in Venus in the coming days. The Aditya L1 mission, as part of our scientific pursuit and PRL and our atmospheric science academia gathering, the first observatory class based on solar mission from India, and we had a halo. It is an halo orbit between Earth and Sun, looking at the corona suns, and we had some wonderful images and understandings, and the way the evolution of the planetary system would have become. We have the work is in progress. It is doing its job, and one of the farthest satellites still active launched from India. Now I'll just venture into some of the future technologies that we are planning. As you know, as we want an ascend and descend, it's a very this one. So we have proven that we can ascend and come back to the Earth with a RLVD technology demonstration mission. Then now when it's coming at 300 kilometers per hour speed and lands, how to do the land, the drop from 4.5 kilometer, we have done all the characterization. So the descent phase also we have characterized, and we are going ahead with our own strip and this one, so that this has a dual technology capabilities, and it is one of the most sought after technology today in the world and well classified. So we are already working on a ORV launch vehicle along with on the top. It's not like a rocket. It has an aircraft type of mounted, which can put a 500 kg payload in orbit and come back, so that we can save a lot of cost. Some of the things which you are going to venture is the human space flight, is to have them people on the celestial bodies. So why it is located is, why the human space program is definitely the space colonization. Researching the universe is one of the best, because I used to tell this in every place. We humans, we don't know the answer for 3 questions. Where from we came, where are we now, and where are we going to in this universe? Actually, whatever we talk is relative, but the absolute answer is still elusive, and it's our quest to know this answer. So some of the technology that we develop to be in space and natural resources, how to get the natural resources, how to harness it, People tell helium-3 is available on the moon. How to harness it? That's also a technology by say. We can provide unimaginable, infinite power requirement that can meet our country's requirement. Something like that. Good. And we have to collaborate with many of the people to complement technology. No doubt, robotics will do all the job much more than the human. But if human has to survive, human has to go to these places. Then only this place. Because human definitely gives on-the-spot intelligence, the judgment, not based on simply on the data. That's why I used to tell my young scientists always, don't go data-driven development, deliverables is really good for the institution. But for the self who is doing this work, it is his or her capability to judge what it is and makes judgment. And that only will develop the person's development. That only will take the person furthermore. Whereas institution will always look for humans, robotics, which will do all the job based on data driven. This is the balance that we have to get in as we go on. I think the time will come where robotics will do much dexterous jobs, which humans will be done based on safety consideration. And we have to complement each other in furthering our scientific flavor and endeavors. So, robotic, as you told, Stephen Hawking is very famous in selling this. Is an iconic statement that robotic missions are much cheaper and will give more results. But human, if you want to continue and survive, we have to go to the places where none has gone before. It's a famous film dialogue of Star Wars, but still holds good. It's copied from Stephen Hawking, I think so. But this is one which makes why human space program is so good. Some of the challenges to reach orbit, the zero gravity. You are used to gravity. Because of the gravity only you are stable. You are listening. Your blood is flowing. But you take both oxygen and water for granted. Actually, South India is one of the places where you can survive without anything. Even you don't require a cloth or housing. Nothing is required. You can survive for 3-4 days without anything. That is one of the best climate, protected. So just go out of this system. When you go to USA or from Antarctic, Arctic, the freezing cold and the latitudes, the northern latitude or southern latitudes, you start not able to manage. How are you going to survive in a hostile atmosphere where you don't have even protection of UV radiation or against UV radiation and other aspects? So you require a reliable launch vehicle. You should have a training, and you have a environmental control and life support systems and the re-entry model that you required for all these things. These are technologies which you look, and psychological function. Your body becomes lean. You will not be used to for zero gravity. You will not be able to walk once you come back to Earth using gravity. These are some of the things which you have to look. So towards this, we have started the program. Lot of technology is being developed. That's why, even though we thought we had all the technologies, but some of the technology development is really required. It is taking time for us to make sure that the human is 100% certified and safe. And at any mishap happens, we can bring those people back to Earth safely. So there are many scopes for the research and development, institution, academia. Now many medical colleges have started the space technology, space medicine, because some of the medicines made in zero gravity and this one has profound effect. The data transfer increases by 2 orders. The near perfect shapes of sphere can be made in space, which can help us in making optical fiber cables, which can increase the data transfer by 2 orders. So these are some technology transfers. There are many more. Plants can be grown without pollution, brought back the seeds, and do many things. And it is a national program which all the stakeholders can do this. So some of the things which I just put in a sample, what we are thinking, it is there in the public domain also. So as part of the things, we want to take the human and experience what are the present generation, the present trend is there in the world elsewhere, and what are the last mile activity that has to be done, because doing 99% is not sufficient. That 1% will kill us. So the Gaganyatri, Indian Gaganyatri group captain Subhanshu Shukla actually performed 7 experiments in ISS, because just going to space and coming back is not the one. We have to do a lot of experiments, and we have to do it for a meaningful, useful purpose. And that's why the Gaganyaan program we told, and we incorporated in the Artemis that along with the US ISS space mission, we went for 20 days and did some experiment and first-hand experience of what all things to be done by an astronaut. The Gaganyaan 3 to be done, we had valuable lessons which we are now imparting into our Gaganyaan program. Now, having done so many things we are doing, what is that we are doing for our own country for the present day life? That also is part of the 75 to 2020. Some of the things of space application technology will do think. I call it a space is nothing but a scientific pursuit for applications with a lot of common sense. What we want, the common sense has been with a little bit of engineering. That's all is called space, nothing else. That's all is for, I put it like this. A lot of common sense should go into this. A lot of logic should go into this. With a multidisciplinary engineering field is put in place, including medicine, everything. And that's what, how do you do the engineering? That is what is placed called, we call it a space. And finally, you should also, as a responsible country and responsible person, you should have a global environmental sustainability. You should not break any of the balances, the fragile balance that we are living in. So that is what we have to now look at, the global environmental sustainability. We all know that India is the seventh largest country with a 1.4 billion and with a 64% agricultural land and 65% of the population depending upon agriculture, with a forest cover of square kilometer, and 4% of world's water resources is in our country. We have to do this. How do we balance? That is what our founding fathers and the pioneers really put a stamp in how to use the technology in the way ahead. And some of the things I'll just venture into this. This is the problem that our country is facing. One of the things. And we cannot just set aside this problem. So, the major issues is the challenge, the diversity, inequality, resources and scale. And if you look, the declining per capita, it is actually decreasing from 2 hectares point to 1.0, half of it, the yield is coming down by half. So these are the issues and the irregular monsoon. And most recent problem is 54% of India faces high or extremely high water stress. This is a map shows. And adding to it, when we don't want water, it comes with a irregular natural distribution of water in India. The agricultural land which wants water doesn't have rain. Those who are not in cultivation has rain. Something is skewed this one. But how do we manage this? And this is where the technology has to help us and put in problem. So let us look at what are the multifaceted roles the technology faces. So we have panchromatic camera, multispectral, hyperspectral imaging, the high resolutions, the data collection platforms, the mobile data, whichever mobile we collect all the data, and the position and navigation system, the DEM, we call digital elevation modeling of the country, the entire model has to be fed into an auto image, the techniques, models, algorithm. That's why even CUSAT has many programs which puts it. And finally, it is to do the water sustainability, the food, disaster management, the urban, governance, and environment. These are the areas which we have to address on the day-to-day time and put in the problems in this moment. Let us see how we do this. First, we look at the integrated watershed development program. First, the satellite imagery, the groundwater, the soil condition, how much land is being used, what kind of drainage system is put in place. All we can map with remote sensing as well as local put. Then we do the water wasteland reclaimed, the fallow lands decrease. Then how do we increase the cropping intensity in which area? The all can be placed. I'm just touching this some samples. Each page what I'm going to present today itself is a lecture by itself. So we can, so this is how the land resource development, we give the information and we can start looking. This is one district in Sikar district in Rajasthan. where we are able to make it useful with the dry wasteland into a cultivatable land and make it this one. And we really did a good job in making it. This is called the Integrated Watershed Development Program. Now, another one is the how do you monitor, implement impact assessment? First, in 2009, I'm just giving a show here in the Integrated Watershed Development Program. We had a dry land. We identified the area where we can have water by the image sensory, and we cultivated the water. Once we did this, we had a very good fertile land. What we are showing is how the imagery is being looked into in the actual locations. And now the watershed program is put in like this. And web-based app Srishti is now available where you can look at these areas and get into a mobile app Srishti. This is called the Integrated Watershed Program with the satellite images, and the entire remote sensing, is by the law of reflectance of many images and waves, RF waves. Based on that, we develop many technologies that can be used for this harvesting of the water. Next is the biggest problem that you are going to come to face is the urban sustainability. We all tell in the areas, everybody moves to urban, and it is today you are seeing every city is struggling and chugging. And how do you make a citizen-friendly, sustainable cities of good quality? So the urban land use, the amenities is one of the four I put, and there are more than 20-25 varieties, parameters are there. We take which are the important things, and these are the problems everybody faces: stormwater, solid waste management, clean energy. So what we do is the Connaught place is the place we image and we change it into multi-layer maps using high-resolution satellite data, looking civil drawing, the drainage mapping, water mapping, DEM, everything put and decide how do we go about it. This is also one of the technologies that can be made use to be put in the urban sustainability. Next is the disaster management. As you know, I will just make it quick because of want of time. Here what I'm talking is we have to identify the hazard zones, the drought and landslides, the floods that we are now doing frequently for the Himalayas and other areas, the cyclone. As we know, India has done wonderfully well in cyclone disaster management. Last 10, 12 years, 20 years, we never had a loss of life because the early warning system, the way in which it's going to hit, all those things been put. And the real data cycling has been already put in place. And this is one of the best one. India is one of the best countries to have the disaster management systems in place. The air quality monitoring, another one aspect. We have the dust moving towards Gujarat in red color. We monitored how it is coming. You can see that. And then it's resulting into a real fog. The aerosol optical depth also is being now captured. And now the entire country, in the entire world, how the aerosol, the storm is passing on, how the India is in the middle of this one storm. That's how we get into this. We also do this map. In the coming days, this is one of the major technologies that has to be developed, arts, and some of the important aspect is the space-based stress gases. We industries let out gases, but how the carbon dioxide, the CO2, the methane, and NO2 gets spread. We do the entire mapping of the country or the industry. This one, which is also important. And how do we address these issues and go? We give all those data which can be made use of. This is how the spacecraft technology comes in, and once you implement some program, how useful it was also can be monitored. I have some lectures define how the food cultivation, the grains can be increased and increase the efficiency of the delivery system, but that is a different subject altogether. I am not coming to this. Now the tele-education, you know very well, it is nowadays everybody has online classes. India is a pioneer in doing this tele-education system. There's a dedicated spacecraft for this and we are now, it is also taken up by terrestrial for the technology development. Now the most beautiful and exceptional experiment was the satellite to the rescue of the fishermen. 35% of our population depends upon the marine and fisheries. The first is the Indian fishing boat. We have put the NAVIC payload. Why the NAVIC is coming in the picture, I'll tell you. The NAVIC chipset in the mobile phone, the smartphone. It has an application, the simple Android-based app. Then it has a native language in different languages of more than 12 to 13 languages of all the coastal states. Then it also gives the international boundary alert once the fishing moves out. Then it gives a high wave alert, the rough sea alert, and the tsunami warning. Based on this, the fisherman gets in real time. Then the most important aspect is the potential fishing stone is already incorporated in invoice. It is available. So a fisherman straight away go to that location by last launch, and he comes back with a bounty of fish in the real time. So his fishing time is reduced. He or she comes definitely with the bounty of the fish. The economy goes up. His wealth goes up. That is one of the major applications which really transforms many of people's lives. And is one of the major success story in the marine, this one. Next is the Navy can use both IRNS spacecraft and GSAT spacecraft, gives command to all the IRNS antenna and gives both for security and this one. And I'll show you some of this one. If I want to say a Delhi City pilot program from Kannada Place to this one, the bus traveling time, the density of the traffic, the way by using the mobile phone intensity, how many people entered, how many people came out, all those can be monitored. It is really surprising that without anybody's intervention, you can get all this data. And you can track your vehicles putting place where it went. You see a boat from Nariman Point in the gate of India. Where did the boat go? Where and all stayed for what time? How it came? Now students should beware. If your mobile phone has to be tracked, we can do all these things and know where you spent the time. You would have seen many times you stand in front of a jewelry shop for half an hour. Don't do anything. Come back. You will end up with a lot of advertisement in your mobile phone about those areas. How did you get that data? So people saying that I have lost my privacy, all those things, I'll put it in a lighter vein. The day you buy a mobile phone and keep it with you, don't think anything is available. Nothing is possible. The data transfer is possible. I'm not selling anything to put some problem, but this is the way the data information is available. And we have to, how well we harness the technology only I'm talking about. So these are some mindset that can be used both in Kerala and this one, even in COSAT academia, of which place, how much time it will take and go, all these things can be monitored if we really put safe mindset in. So then one of the important aspects is the safety through the satellite communication, satellite navigation application. More than 1 lakh railway crossings are there without anybody, with no crossing, unmanned crossing. So just we can't put any safety gadgets there because the theft is one of the biggest problem. So what we put is a alarming mic. Just as the railway crossings 2 kilometers away, the train starts giving a beep sounds, its horn, and just 1 kilometer before it starts crossing the railway, it will give a very long horn, and it will cross. The people may be aware, and this is where the real-time train tracking, along with the approaching train, we can give and we can avoid any train crash. And that's what we are demonstrating. This concept is being demonstrated, conceptually successfully completed, and we avoid any accident in this because the speaker there will start announcing that the train is coming at what distance and how we can avoid this. This is one of the beautiful concepts of marrying both satellite navigation and SAT applications. As we go, we can't do it alone in this world. So we all started with asking for the request, shaking hands. First, then USA competed who has to be best nation in space, but we started applying, we started coordinating, we started cooperating. Today we are complementing each other, and today we are sitting across tables with the different nations and do this work. So it makes economic sense, right? When you make Chandrayaan-1, it makes some economic sense because we are showing that we have the technology to go anywhere. So we become partners in progress. The GSAT-9 is a South Asian satellite for all the people, and NISAR is a long-term space diplomacy and long-term. As we go, we have more than 230 agreements with different 55 plus countries, and we had enhanced our rest observations, exploration, the Gaganyaan, ground station work, supporting the aspiring nations for all these aspects. And this is where we deal test observation, the communication, navigation. We can ground station as a service because we can service other nations' requirement also. Then we start exploring all this. Don't worry, lawyers have a job. Space law is one of the most flourishing business in this because the business is multi-billion. India's contribution is already 8 billion now. We are aiming to make in another 5-6 years to 44 billion. The world is 240 trillion. So if you want even 5% of the market, the big work is there for corporate and laws. And space law is one of the ongoing subject because as in the coming days, in 50 years time, I can say at most 1 lakh people will be there in space. Once in a while, they will come to Earth on leave to spend their time, free time, and then go back. People may like to live in space, and that's what's going to happen. And just a glimpse, for every 1 rupee that we added as a direct impact, 2.54 rupees are generated through indirect and induced ones. So it is the national economies to be stimulated. So around 4.7 million people are helped, and public fund is 24 billion tax revenues, and stimulating national economy by 60 billion. Definitely, industries and academia has a large role to play in many supporting these human resources, supporting space technology and putting and impact, socio-economic impact in India's space program. I don't have to say how much it is there. Now coming to this future. Definitely Gaganya, the follow-on missions, the Bharatiyandra space station, already we have started the work. We are going to put a space station in place by 2028, human mission to moon by 2040, and Mars and beyond. Just how this, some of the youth, I am actually used to tell, I am jealous of this generation, younger generation, because we didn't have a choice. We have to work here, slug it out. Today you have multiple choice. It is for you to make it as among the community of nations, as India as a powerful manufacturing powerhouse and should be the go-to country for getting any item delivered. And that is there in the next 20 years. It is in your hands. And that will enable not only technology, not only going to space and going to the future outposts on Moons and Mars. These are all not some dreams. These are some conceptual. People are already working. People are already living in this such of areas for 1 to 2 years, volunteering to see how to live in Moon, how to live in Mars under habitat condition. All this possibility exists. And I will wish you the generation that is come to work. We are all going to be in the advisory role, or we can tell what we know, and you have to do this work to make the country a powerful one. Some of the spin-off from these applications are the advanced ceramics, the energy systems. Your batteries are improved like anything. Today we have EV vehicles. It's because of space technology. Because we have limited space, but we have to produce huge power. That's what is made. We can have the artificial heart, the microprocessor control limb, successfully now controlled. One core worth material now we are making in 5 lakhs. The ventilators, the medical oxygen concentrators, the structural analysis, some of the analytic tools that we have developed. VSSC alone has 271 patents filed, 315 technologies transferred to the industries by VSSC. And these are the direct benefits. And some of the strategies for the future, Atmanirbhar Bharat, with academy and industry, with the startups and MSME, the research, space education, space-to-based applications, and doing it in the many space technology in many industries and many academia is going to pay way for the. I wish you all the success in coming days and hope whatever little bit I am able to give as part of my experience and as part of my organization, Vikram Sarabhai Space Center and ISRO, which enable you to look at this area much more human-friendly, sustainable, and make yourself valuable in the coming days. Wish you all the best and wish you CUSAT all the best in the coming days in its research and development of the human resources. I hope you have a very good year ahead and wishing you the best. Thank you.
Thank you, sir, for that insightful and thought-provoking lecture. We'll now have a short interaction. Due to time constraints, we'll have 1 or 2 questions.
Thank you, sir, for your detailed talk on ISRO activities and upcoming missions. My question is related to Chandrayaan missions. In Chandrayaan 1, ISRO detected the presence of water on moon mission through mapping and all. But in Chandrayaan 3, we did some in situ experiments using alpha particle experiments or laser-based experiments, but we did not get any direct evidence of water on moon using the devices on or payloads on Pragyan rover. What could be the reason?
Okay. It's not we are looking for some particular minerals, and the whole entire Chandrayaan 3 experience is only for landing. Can we soft land? And the rover, can we go on the rover? There are some understanding how the surface is going to be. We thought it is very dusty, but it is not so. But at the same time, it's not very hard also. So we did the drilling experience. We did some of the work. And most important aspect was have landed. We can't be there. We have to come back from moon. So whether our technology is capable of lifting off from moon also we have to see. Because of the Earth, we don't have a launch pad like system that is there on the Earth. We provide a platform like airport we have. But once you go on the moon, how to come back from the moon? This is also one technology. It's not that easy. So that also we tried in Chandrayaan 3. These are the priorities. It is not the water is a priority. We went to the south zone, South Polar region to look at the other aspects, which I don't want to get into details. That is what our priority is. And with the 14 days of lifetime on there, it's very slow time to gather such kind of results. For that, we have to go and land in places where we mapped where the water vapor or water ice can be there. And we have to drill deep, not this 10 centimeter, 5 centimeter. Hope I have given you the clarity.
Okay, sir. Thank you.
Hello, sir.
Yeah.
I'm representing IRIS-SETS CUSAT. We are the official space club of Cochin University of Science and Technology. My question is, so what are the key challenges that VSSC is expecting while launching and assembling large modules like Bharatiya Antariksha Station, BAS?
Yes. Bharatiya Antariksha Station is not only VS's job. It is a combined national work by different centers of ISRO along with the academia and industries all across the national project. Our job is to do the looking at the structure and do the micrometeorite protection. So we will be making the structures. The assembly and aspects will know in another center and then get prepared in the Sriharikota. So there are many aspects. So the fabrication is going to be mainly from industry. The design and other aspects is going to be from Vikram Sarabhai. That's how we look at it. So difficulty wise, it is like, have you seen aircraft? Have you ever imagined in such a volume for 200, 300 international aircraft, for 200, 300 passengers, they have food, they have water, they have toiletry facilities, they have put everything, they come back. You have to look at the structural design. It should not vibrate. Humans are going. So we look at the environment, space available, how we are going to, as I indicated, environmental control and life support system, which is the most important, most difficult to be put in place. And that is the one we struggle to put in place, which LPAC, another center in Trivandrum, which is working on it, along with VSSC for the avionics. And we all put it, and the URSC, which is the nodal agency for the any orbiting asset, that will put in place and will be done. So that's how we are using it. And yes, it is first of its kind. It has its own challenges, but at the same time, there is an excitement also. And that's only will take us to. Thank you.
Thank you all for the engaging discussion. To formally conclude the proceedings, I invite Dr. Deepthi B, Junior Scientist KCST, to deliver the vote of thanks. So good evening to all. On behalf of the Kerala State Council for Science, Technology and Environment and the organizing committee of the PR Pisharoty Memorial Lecture, it's my privilege to propose vote of thanks for today's program. So our deepest appreciation goes first and foremost to our
Speaker Sri A. Rajarajan, Director, Vikram Sarabhai Space Center, Trivandrum, for delivering the PR Pisharoty Memorial Lecture. So thank you for your valuable time and insights with us, and also for inspiring the audience to your address. I am deeply grateful to Professor M. Junaid Bushri, Honorable Vice Chancellor, Cochin University of Science and Technology, for delivering the presidential address and also for constant encouragement extended to this program. Okay. I'm deeply grateful to Dr. Alton Anthony, Associate Professor and Head, Department of Physics, CUSAT, for the warm welcome and for all the support to host this program at CUSAT. So thank you. My heartfelt thanks to Dr. Sajish T.H., Vice Principal, St. Edward's College, Ernakulam, for thoughtful introduction to Dr. P.R. Pisharoty, for reminding us his pioneering contribution and entire legacy. Thank you, sir. I also thank Sri Arjun Prasad, Scientist KCST, for introducing the speaker and also for setting the contest for today's memorial lecture. So thank you. So we thank all the participants, including teachers, students, and researchers for your participation and also for making this event truly meaningful. Thank you all. A special word of appreciation to Department of Physics, CUSAT, the organizing team, supporting staff, and volunteers from both KCST and CUSAT for your meticulous support and coordination, and also which ensure the smooth conduct of this program. Thank you. So finally, we remember with deep respect Dr. P.R. Pisharoty, a pioneer whose contribution will continue to inspire us. And we are grateful to everyone for joining us for this memorial lecture. This is conducted as a prelude to the 38th Kerala Science Congress, and which is going to happen in St. Albert's College from January 30 to February 2nd, 2026. So be a part of that event. Okay, thank you all.
Thank you, ma'am. Before we disperse, a few important announcements. Refreshments are arranged outside the auditorium. E-certificates will be sent to your registered email IDs. Kindly scan the QR code displayed at the registration counter outside. For updates on the 38th Kerala Science Congress, please follow the official social media handles and visit the website. We encourage all participants to complete their registrations at the earliest. Thank you all once again for your presence and active participation. Wishing you all a pleasant day ahead.
Thank you, sir.